let's talk about everything to do with the sun. So best place to start is at the beginning. So where do suns come from? Where do other stars come from? Where do planets come from? The easy answer is nebulae. So there's lots of these different nebula around. This is the Orion Nebula. So if you ever looked at the constellation of Orion, just below the 3 stars in this belt is the Orion Nebula. You can kind of see it's like a fuzzy patch with your eyes. You can't really see it very well, but if you zoom in, you get these nice pretty colors. So you got these pinks and these kind of purples and blues. What this is it's a big cloud of gas and dust. And over time, these bits of dust, I'm talking like little tiny bits of dust like you'd find in your house, like, where this one hasn't cleaned and stuff like that. These little bits of dust will bump into each other and they'll start to stick together. And then they'll get bigger and bigger, and then more things will stick into them, and then they'll start to get gravity, and then they'll attract in more things, and they get bigger and bigger and bigger until they form planets and stars. And so what happens is that's how our solar systems come from. That's where our sun came from. Everything that you know came from one of these nebula. As I said, this is the Orion Nebula. We can jump over to a different one. The Orion Nebula is, I say, fairly easy to see with your eyes, and so you can see this kind of fuzzy patch. Let's jump over to the Eagle Nebula, which this one you can't see, it's quite far away, but we get some really cool pictures of it. So this one is this kind of reddish color. In a second, I'm gonna get a much higher quality picture and it's gonna sharpen up. But we can kind of see, there we go, and it's just popped in. So this is from the James Webb Space Telescope. It was taken a couple of years ago, and we kind of got this like hand structure in the shape of the clouds. So we can see, all these lines and stuff in the clouds. And all the dots you can see, like in amongst the clouds, is all different stars. So what happens is when the stars are born, they kind of then will migrate outwards. So it's like, we call them like stellar nurseries. It's almost like a baby going to nursery. When it gets old enough, it will leave and move on to the next stage of its life. That's what happens with stars and planets too. The other thing as well you can see here is you can see all the different colors. So you can see lots of like yellows and blues. There should be some red ones in here as well, but you can't really see those very well. It might be to do with the filters on the telescope. But yeah, stars are also different colors, and this is depending on what temperature they are. So blue stars are hotter and red stars are colder. The opposite of what you think it would be. But yeah. So anyway, that's where stars are born. As I say, our star would have come from one of these. So what happens is, like I said, everything kind of sticks together, but sometimes when the stars are kind of forming, they don't actually get big enough to become stars. So if we jump over this constellation called Sails, what will happen is you get something called a brown dwarf, and these are really hard to see because they're really dark. But in the Sails constellation, there is one. So this is what we think it would look like. But as I said, they're really hard to see because they're not very bright. And they're kind of this halfway between a planet and a star. So there's almost like a lava planet type thing. And so, yeah, they kind of have this like reddish orangish glow to them. We think there's quite a few out there, but like I said, they're really hard to find. So it's a little bit difficult to know exactly how many and where they are and stuff like that. So let's move on to the main event. So the sun. Our sun is, pretty average when it comes to stars. It's not the hottest, it's not the coldest, it's not the biggest, it's not the smallest, it's pretty average. Unlike planets, like the Earth that has rocks and stuff, the sun is made of plasma. The easiest way to think of this is like lava. It's kind of this like liquid molten thing that kind of moves around. You can't really stand on it, you kind of sink through it. We do think of the sun as having like a ground, even though you can't stand on it. We kind of think of that as like where things are different. So like on the Earth, underneath the ground, you have like lava and things change and stuff like that. And then above the ground, things change again. So we kind of have that point on the sun. It's just a little bit harder to define. It's more like the geology and stuff, I guess, even though it's not rocks. So we can see this is kind of the surface here, and then up here you kind of got these clouds and stuff kind of coming off where the sun does have an atmosphere as well. You might be able to see these black spots on the sun as well. These are called sunspots, and they kind of appear and disappear as stuff is going on with the sun. It's usually depending on how much energy the sun has. So the more energy the sun has, the more sunspots there are. We have just finished what's called a solar maximum, so that's when the sun has a lot of energy. The sun goes through this 11-year cycle where it has lots of energy, and it has like no energy, and then it has lots of energy, and it kind of keeps going as long as we've been watching the sun. So about a year or two ago was when we hit the solar maximum of when there was the most energy on the sun. In about 5, maybe 4 years' time, there'll be almost no sunspots on the sun. And these also correlate as well with the northern lights. So you might have seen like a year or two ago, lots of people were posting pictures of the northern lights. Places like the UK saw the northern lights, which we normally don't. And that's because the sun was in a maximum where it had lots of energy, and it means the northern lights are a lot stronger. In a couple of years' time, nobody will see the northern lights. There'll be very little of them. Whereas if you're planning your trips to go to the Arctic Circle to see the northern lights, book it for about 10 years' time, and you'll have a pretty good chance of seeing the northern lights. I'm going to jump over to a different program a second, this one. So what we can see here is there is kind of like structures in the surface of the sun, and this is just where different parts of the plasma are different temperatures. Yeah. The other thing as well we see is on Earth, right, it takes you 24 hours to have a day, right? For the Earth to spin around once, no matter where you are, it's 24 hours. Obviously, you get different amounts of daylight and nighttime depending on where you are and time of year and stuff like that, but it's still 24 hours to go around once. It's not like that on the sun because it's almost like a big ball of liquid. It spins at different speeds, so the middle actually spins faster than the top and the bottom. And this does create issues, and that's also where some of the sunspots come from, is from this spinning, and it causes all sorts of weird things with the sun's magnetic field, because the sun is also like a giant magnet. If I switch back to this one, you can see this is like the North Pole up here, and this is the South Pole down here, where like you get these lines coming out, and the Earth is the same, where it has these, but we can't see them, they're invisible. So yeah, that's the sun. Let's move on. So, as I said, the sun is pretty average, it's middle-aged, it's kind of halfway through its life. One day the sun will die, all stars will die, but it's not for millions of years, so we don't have to worry about it. If we go over to Orion, if I turn on the constellation lines, we can see it a bit better. This is the constellation Orion. We've got the three stars of his belt down here, and we've got the Orion Nebula down here just off the screen. In the top left of Orion, you've got the star Betelgeuse. Betelgeuse is dying at the moment. So what happens when a star dies is it turns into a red giant. So the star becomes really unstable, and it gets a lot bigger, and it turns a lot more red. So when the sun dies, it will get bigger and kind of eat up Mercury and Venus. We think Earth is going to be okay. It's a little bit unclear on the specifics. But yeah, Mercury and Venus are definitely going to get eaten. As a Betelgeuse is dying, and we know it's going to be the next one to kind of die. So let's take a bit of a closer look. I'm just going to turn the lines off. Let's zoom in on Betelgeuse. So we know it's going to go supernova soon, so this is when it's going to explode. But soon in astronomy terms could be tomorrow, it could be in 200 years, we're not quite sure. So yeah, we're seeing it's kind of going a bit more red, a bit more orangey color, and we're seeing it's getting a bit bigger as well. So what happens is when the red giant kind of forms, it will then explode into a supernova, and supernova are very, very bright. And they also create all these really cool shapes and stuff. So yeah, we're waiting for Betelgeuse to go supernova. Let's move on. I can show you something else. And yeah, supernova are very bright. The last big one was about 400 years ago. And apparently it was like there was no night for 2 weeks. And this is the kind of what they kind of create. This will sharpen up in a second. So you kind of get what's left over, we call it a neutron star, and then you get this big like shapes of gas around it. These ones happen to be rings because this is called the Ring Nebula. So this one, I think it's this star right in the middle. It's not the bright one. I think it's this one. Is the one that created this nebula. So you get nebulas at the start of the sun's life, and you get nebula at the end of the sun's life as well. And as you can see, it's all this kind of gas and dust again. It's a really cool one. Lots of pretty colors in here. When you have a supernova, this is when you create a lot of the other elements on the periodic table. So at the start of the universe, before there was any stars, we only had hydrogen and helium. And then now when you have supernova, they create all these other things. So things like gold, iron, copper, zinc, lithium, lithium fuel batteries, they all come from supernova when stars explode. Yeah, this is a really pretty one. Let's move on. There's another one I can show you. The best thing about astronomy is lots of pretty pictures. All these really pretty pictures, when it kind of sharpens up, are from the James Webb Space Telescope. It's been getting some really amazing photos throughout the universe. So this is the Crab Nebula from the northern hemisphere. We can't see this. This is a southern hemisphere thing. Again, it will sharpen up in a second. There we go. So again, you can see this one much more clearly. You can see all the lines of gas through it. So you've got all these big orange shapes of this kind of structure of the gas left over. We don't know which star created the Crab Nebula, but yeah, it's still pretty cool. And you also, even in the white smoky bits, you can see lines in this as well, where there's all these kind of structures. And these nebula might create other stars in the future as well, which we'll have to kind of wait and see. This is the one I was kind of talking about. This nebula was created by a star that was about 400 years ago that was so bright that there was no night for like 2 weeks. Betelgeuse that I talked about is closer than that star was. It won't harm us when it does go supernova, but it will be very bright and you definitely won't miss it. Okay, so most stars turn into red giants when they kind of die. If you have a really big star though, they turn into something else, which is everyone's favorite thing, a black hole. So let's take a talk about that. So if we jump over to the Virgo galaxy, you've probably never heard of this galaxy. I've never heard of this galaxy, but at the very center of it, there is a black hole, and we have managed to get a photo of it. So just give it a second and it will load up the photo for us. Most galaxies do have black holes. There we go. You might have seen this picture. It was going around a lot a few years ago. This is the first photo of a black hole. I think there's been a couple since then, but this was the very first one. So it's really hard to get a photo of a black hole because they kind of suck everything in and nothing comes back out. But what we've seen is actually some of it does come out. So when your sink is full of water and you're emptying out the sink and it kind of swirls around, sometimes when it's swirling around, some of the water gets flicked back out and like will splash up against the sides. The same thing happens with a black hole. Sometimes some of the light that just goes inside the edge actually gets swirled around and thrown back out again. We're not super clear on why or how this works. Black holes are still very mysterious because we just can't really look at them very well. This was a very hard photo to get. But you can kind of see the kind of swirling of the shape of the black hole as it kind of goes round. So yeah, for bigger stars, what happens is when they go supernova, all stars leave behind a neutron star, which is a really dense kind of ball about the size of like a city, and it's really, really dense, very, very heavy. Like a teaspoon of this, we call it a neutron star, a teaspoon of a neutron star weighs about as much as your car. So it's very, very heavy. What happens is if the star is very big, like much bigger than our sun, that neutron star will be even denser. So there's even more like atoms packed into it. So your teaspoon, rather than weighing the same as one car, might weigh the same as 10 cars, just where it's a much, much like thicker material. And what happens is that kind of rips a hole through space and creates a black hole. Again, we still don't know much about the black holes, but this is kind of the theory of where they come from. Our sun won't turn into a black hole. It's not big enough. That'd be pretty cool if it did, but unfortunately it won't. But yeah, that's kind of everything there is to know about the stars and the sun. Hopefully got some fun facts there, and I will see you in the next Planetarium show.